Alright, so right now we're going to go through how to find if a truss is statically determinate. And basically what that means is that when you look at a truss and when you go to calculate it, you can actually go in and actually calculate it, and it will actually hold. It will actually work in the math equations. So that's one of the first things you want to do before you actually go through and find out all the magnitudes and if a member's in tension or compression. Before you do anything with the truss, you want to find out if it's even possible, if it will even actually work. So you want to find out if it's statically determinate. It's a pretty easy formula to go through, and basically what it is you're looking at 2J equals M plus R. And just to kind of recap, for those of you who don't remember what the J, the M, and the R stand for, the J stands for joints, the M stands for members, and the R stands for reactions. Okay, it's pretty simple, pretty easy. As you can see, we have a truss above. We have a truss above, but it doesn't actually have any supports on it. So I did that for two reasons. Number one, I want to add my own, and I want to do it a couple different ways. That way you can see what it looks like when it is statically determinate and what it looks like when it's not statically determinate. So we're gonna put some in here. See if we can get a color that we're going to see. So we're going to put one on the left here. And for those of you who don't remember, if it is a triangle, it is a pin. If it is a circle, or anything that has a circle on it, it's a roller. And those of you who, again, if you forget which is which and what has what on it, we're going to just do a quick recap here for you so you can remember. A pin holds structures in two directions, along the X and along the Y. And a roller holds it not exactly in the X or the Y, but it's always perpendicular to the surface. So the surface right now in this drawing is going left and right. So the roller is going to hold it perpendicular to that surface. It's going to allow it to move left and right. It's not going to allow it to come off that surface. Hence why it's a roller. It allows it to move along the surface, doesn't allow it to come off the surface. So I'm going to put a roller on this side. And you may see rollers drawn in a few different ways. You may see it as a circle with a couple lines on it. You may see a couple circles with lines. Whenever you see a circle, it's a roller. And even when you see a triangle, it may look like this. It's still a roller. That's still a roller because it has circles. All right. So right now we're looking at a drawing, and it has, we're going to go through, we're going to have to count them. So we're going to go through and we're going to count these guys. See what they look like. And right now the computer's kind of fighting me. And we're back on track here. So we're going to go through and we're going to put these guys on here. Alright, so first thing we need is the number of joints. Where the joints are is where more than one member they connect. So whenever two or more members connect is where there's a joint. So I'm just going to circle them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 joints in this drawing. So the number of joints in this drawing is 12. Let's count the number of members. And a member is just a straight line. So we're going to go 1, 2, maybe I'll just write it on here for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So the number of members is 21. So now we need reaction forces. Well, reaction forces deal with pin and roller. So a pin has 2 reaction forces. A roller has 1, so 2 on this side, 1 for the roller, so we get reactions of 3. So let's put in our formula. We have 2 times J, which is 12, equals 21 plus 3. So 2 times 12 is 24, equals 23, or I'm sorry, 21 plus 3 is 24. So it checks out. So this one is statically determinate. It's good to go, ready to go. So what happens if it doesn't? What happens if it looks like it doesn't? So what we're going to do is easiest way. I'm going to do a little quick erase. And the members are going to stay the same. Joints are going to stay the same. The only thing that's going to change is instead of a roller over here, we're gonna put 2 pins. Come on. We're going to put 2 pins. So I'm going to put another pin over here. And we get a pin. So now, the only thing that changes, we have 2 times 12 equals, we still have 21 members. But here's the difference now. The reactions have changed. So now we have 2 for this pin and 2 for this pin. So we have a total of 4 reactions now. So we get 24 equals 21 plus 4 is actually 25. So what you'll find is this does not work. So it is not statically determinate. So whenever you get a question that asks if it's statically determinate, use that formula right there. 2J equals M plus R. Basically count the number of joints, count the number of members, and figure out how many reaction forces there are. And it's basically pretty simple math. And if it equals, it's a check marks. And if it doesn't, it does not. It is not statically determinate. Pretty simple question. Just take your time on it. Make sure you're counting everything. And I will say one of the mistakes is some people, instead of counting these individuals, like this guy and this guy and this guy and this guy, they'll count this whole member as one. And really it's 4 individual members because there's joints in between it. So that all those joints separate them into different members. So you have to make sure you count those individuals, not as a whole large guy. Alright, so that's been pretty easy, and look forward